Here we're asked to use triangle PIN to complete the parts below. So first thing it asks for is to calculate the exact length of line IN, which is this right side here. So the first thing I'm going to do, because this is a right triangle, I can use Pythagorean theorem. And if you remember, that is a squared plus b squared equals c squared, where a squared and b squared are what we call the legs. The sides that are not the hypotenuse, and then c is our hypotenuse here. So we're going to say 3 squared because that's our first leg, plus the line that we're looking for, I'm going to call x just because that's my most common variable, and then my hypotenuse, which is 6 squared. So as I go through this, I get 9 plus x squared equals 36. Then I subtract 9 from both sides, and that gives me 27. And then I take the square root. And a couple of things about this, when I take the square root, I really get plus or minus the square root of 27. But because I'm looking for the length of a triangle, I can't have a negative length. So we're really just going to be using the positive value here. So IN is equal to the square root of 27. Second one says write and simplify a ratio for cosine of angle P. So cosine, if you remember SOHCAHTOA, if I'm talking about cosine of an angle, cosine of angle P is equal to the adjacent side, which in this case, the adjacent side is 3, and the hypotenuse, which is 6. So 3 over 6, which can simplify to 1/2. So I wrote the ratio and I simplified it to 1/2. So cosine of P is 1 over 2. Last one here says write and simplify a ratio for sine of P. Well, sine, SOH, represents the opposite side, which opposite of this is across. And I know that that is equal to the square root of 27 over, oh man, I made a mistake. I forgot to simplify the square root of 27. I'll come back to it. So square root of 27 over the hypotenuse, which is 6. So real quick, what I realized is I didn't simplify the square root of 27, which is my bad. I'm going to do this in red because how dare I. The square root of 27 is the same thing as the square root of 9 times the square root of 3. And I know the square root of 9 is just 3. So really, what I should have said is that IN is equal to 3 root 3. So again, make sure that you double check as you go through, unlike what I did. And so finally, going back to C here is that if I have sine of P, it's 3 root 3 over 6. And then I can simplify this to be root 3 over 2. Now, what we might notice when I'm going through this is that if cosine is equal to 1/2 and sine is equal to root 3 over 2, then this might be one of our special triangles, our 30, 60, 90 triangles. So as we go through here, we got to know Pythagorean theorem is a squared plus b squared equals c squared. And to find sine and cosines, we got to know how to use SOHCAHTOA.